Hi everyone, today we are going to discuss calculus. To start with calculus, first we have to discuss what is derivative. Suppose we are given with a function, the derivative of the function will be the equation of the slope of the tangent to any point on the function. Here we have a function fx whose graph is plotted here. At any point x is equals to a, the slope of the tangent can be f of a plus h minus fa over h, where we have a limit that s tends to 0. So in simple definition we can say that derivative is the rate of change in fx with respect to the independent variable x. We know that fx is denoted by v, so we can say that derivative of function is change in y over change in x, that is also our slope, and slope is also known as gradient. We know how to find the gradient of a straight line, but here we have to find the gradient of the tangent at any point on a curve or a function. To start with, we have a linear function fx is equals to 2x plus 3 that demonstrate a line. Let's pick 2 points 1, 5 and 2, 7. The slope between these 2 points, or we can say that the slope of these 2 points on a line will be m, that will be change in y, that will be 7 minus 5 over 2 minus 1, and it will be 2 over 1 equals to 2. Likewise, we can take another point on the line like 0, 3 and 2, 7. The slope will be 7 minus 3 over 2 minus 0, that will be 4 by 2, and it will be 2. So we know that in a straight line the slope is constant, the slope never changes, and here the gradient that we discussed is average rate of change in y with respect to x. In derivatives we deal with instantaneous rate of change between dependable and independent variable. Clear? As we discussed, in a straight line the slope is always constant, or we can say that the instantaneous rate of change or the average rate of change will be equal. For example, if we pick 2 points 0, 3 and 2, 7, when x changes from 0 to 2, then y changes from 3 to 7. This means that delta x is equals to 2 and delta y equals to 4. So delta y over delta x will be 4 by 2, that will be equals to 2. If we take any other point on the same line, our gradient will be the same. So here we discuss the gradient of a straight line, and we can also find the gradient on any curve, the gradient of any curve. So rate of change or gradient in a curve, we are given with a curve y is equals to x square. This is a quadratic function. When we take this point 1, 1 and 2, 4 on the curve, the rate of change will be delta y over delta x, so it will be 4 minus 1 upon 2 minus 1, this will be 3 over 1, and the rate of change will be 3. Here we have 2 points, so this rate of change is our average rate of change. If we take any other 2 points like 1, 1 and 3, 9, so the rate of change will be 9 minus 1 will be 8 and 3 minus 1 will be 2. so the rate of change will be 4. Unlike a straight line, the rate of change between any 2 points will be different, or we can say that will not be always same. In this case, we have to find instantaneous rate of change at any point on the curve, that is our derivative. Okay, suppose we have a point P. Coordinates of P are x and x square. Means at x, we know that this is a quadratic function, fx is equals to x square. So at x it will give you a value of x square. We have to find the instantaneous rate of change. Let's have another point Q that is close to P at x plus h. So at x plus h the function will give you the square of x plus h. So the rate of change from P to Q will be change in y over change in x. Change in y is fx plus h minus fx over x plus h minus x, that is fx plus h minus fx over h. So now, as we know that tangent only passes from a single point on the curve, so this h must be very close to 0. So we will take a limit that h tends towards 0. So it will give you instantaneous change at any point on the curve. So it will be x plus h square minus x square over x. On expanding, we will be having limit h tends to 0. X plus h square will be x square plus 2 times x plus h square minus x square over h. X square and negative of x square will cancel each other. Now the limit h tends to 0. The remaining two terms in the numerator have h in common. Let's take it out. So it will be 2x plus h over h. Cancelling the h. So now we have an expression limit h tends to 0, 2x plus h. On applying the limit, we will be getting the instantaneous rate of change of the curve equals to 2x. This means that at any point on the curve y is equals to x square, the slope of the tangent will be equals to the 2x. So f dash x is 2x. Means at x is equals to minus 3, somewhere here x is equals to minus 3, the slope of the tangent will be 2 times minus 3 and it will give you a minus 6. This means that here the rate of the change of the slope is minus of 6 units, or we can also say that at this point at x is equals to 3, the slope of the tangent is negative of 6, means it is decreasing. So if we are given with any function fx, its derivative can be written as limit h tends to 0 fx plus h minus fx over h, and this formula is known as our first principle of derivative. Using this, we will try to find the derivative of a function y is equals to x raised to the power n. So dy by dx or delta y by dx will be limit h tends to 0 x plus h raised to the power n minus x raised to the power n over h. Using binomial theorem, when we expand x plus h raised to the power n, we will be having x raised to the power n plus n x raised to the power n minus 1 times h, and so on. It will go till h raised to the power n. On putting this into the equation, we will be having limit h tends to 0 x raised to the power n plus n h x raised to the power n minus 1 and so on till h raised to the power n minus x raised to the power n over h. This x raised to the power n and negative x raised to the power n will cancel each other. Now we have to take care of this h, because when we put limit h tends to 0, this expression will be infinity or will be not defined. So as we can see that each term in the numerator have h as common, so it will be limit h tends to 0 on taking common factor h outside. So we'll be having n x raised to the power n minus 1 and all the terms containing h here. This h and h will cancel each other. Now when we put the limit, it will be n x n minus 1, and except this term all the terms have h within it, so all will be equals to 0. So the derivative of y is equals to x raised to the power n is n x raised to the power n minus 1. So we can say that f dash x is equals to n x n minus 1. Likewise, we can easily obtain the derivative of any function using first principle of derivative. So here the derivatives of many common functions that we use in mathematics are given here, like y is equals to x raised to the power n sine x, cos x, exponential function, logarithmic function, and so on. Here we will try to find the derivative of sine x. So fx is equals to sine x. Applying first principle of derivative, the derivative of this function will be limit h tends to 0 f of x plus h minus fx over h. So it will be limit h tends to 0 f of x plus h will be sine of x plus h minus sine x over h. Here we will be using formula of sine of a plus b, and it is sine a cos b plus cos a sine b. On applying this formula, we will be having limit h tends to 0 sine x cos h plus cos x sine h minus sine x over h. If we notice in the first term and the last term, we have sine x as common factor. Taking out as common, it will be sine x cos h minus 1 plus cos x sine h over h. We are also familiar with the formula of fraction, like a plus b over c is equals to a over c plus b over c, and we will be also using the algebra of limit, that is limit of fx plus gx. It is limit of fx plus limit of gx. So if we have two functions and we have to find limit of their sum, we can find the limit of the individual function and add them. So here it will be limit h tends to 0 sine x cos h minus 1 over h plus cos limit h tends to 0 cos x sine h over h. Now we'll be again using some formula, like limit x tends to 0 sine x over x is equals to 1, and limit x tends to 0 cos x minus 1 over x is equals to 0. By applying these two formula, we will be having sin x into 0 plus cos x into 1. So it will give you overall cos of x. So we can say that derivative of d over dx sin x is equals to cos x. Hope you guys are clear with the concept and can easily go through the questions. Thank you.